Hello, and welcome to my Pre-Algebra review series. This video addresses Chapter 1, Section 1-1, titled Variables and Expressions. By the end of this video, you will be identifying numerical and variable expressions and be writing variable expressions. These mathematical skills are a start and necessary part of your learning journey into the world of algebra. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to answer each and every one as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's get started. Okay, before we get started, I have a couple definitions to go over here. So the first is variable. A variable is a letter that stands for a number. That's all it is. It takes the place of a number. The difference is that variable can be any number, but it's standing for a number. And a variable expression is a mathematical phrase that uses variables, numerals, and operation symbols. Okay, so that's all. And an expression says like A equals B plus 3. Those are letters for variables, and the 3 is a numeral, and that's a phrase because it has a equal sign in it. That's an operation symbol. Okay, there you have it. Okay, objective 1, identifying variables and expressions. Gas mileage. How many miles can you drive on 10 gallons of gas? The answer depends on the type of vehicle you drive. The table below shows some typical cars. So we have vehicle type, miles, gallons, and miles per gallon. And we have 5 different types of cars. We have a subcompact, a compact, a mid-size sedan, a sport utility vehicle, and a pickup truck. And as you can see from these 5 vehicles, the mileage goes up on 10 gallons of gas. You can drive on a subcompact, you can drive 330 miles on 10 gallons. And a pickup truck, you could only drive 160, according to this chart anyway. And we're saying that in this chart, we're also saying that in each case, it's 10 gallons. So 10 is common. It's a standard in our experiment here. And the miles per gallon, what are the miles per gallon? Well, for the subcompact, the miles per gallon is 330 divided by 10. So it's 330 miles divided by 10 miles per gallon. Okay. The gallons are what you're in, so you're going to end up with 5 miles per gallon or whatever what it'll be. So 33 would be 330 divided by 10 is 33. The compact is 300 divided by 10, which is 30 miles per gallon. And that's kind of what our chart. The pickup truck says 160 divided by 10 is 16 miles per gallon. So the last column gives the numerical expression for each vehicle's miles per gallon. That's a numerical expression. So if you don't know the number of miles, you can use a variable to stand for the number, and then you can write the variable expression for the miles per gallon. So here we're talking about this right down here at the bottom here. We're talking about writing a variable expression. Okay, right here for right here, variable expression. We're going to use one for the miles per gallon. And we're going to, in words, what is it? The variable is m for miles. Typically we do that with variables. Depending on what the variable is, you use the first letter possibly of the name of whatever it is you're looking for, or whatever the name of the variable is. Miles, distance, time, height, width, whatever you get, h, w, t, okay? And then miles on 10 gallons is what the m is. And the variable expression is m divided by 10 is equal to miles per gallon. So you can see that's the variable expression. That's like the key thing in the future in your equations. Okay, example 1, identifying expressions. Identify each expression as a numerical expression or a variable expression. For a variable expression, name the variable. So A, 5 minus 5, is that a numerical or a variable expression? And obviously the answer is right here, but think about it. There's no variables in here, right? All there are 5 minus 5, so it's a numerical expression. 5 minus 5 is 0. For B, it's C minus 5. Is this a variable expression or is this a numerical expression? Well, it's a variable expression because C is the variable name. There it is, C. That's the variable, and we've named it according to our little example here. Okay? Okay, example 1, let's check your understanding. Directions. Identify each expression as a numerical expression or a variable expression. For a variable expression, name the variable, same as we just did on the previous slide. So let's go. A, what is 8 divided by x? Is that numerical or variable? It's a variable expression. And what's the name? What is the variable? The variable is x. B, is B a numerical or a variable expression? Yes, numerical. And there is no variable because it's a numerical expression. And how about C? D plus 43 minus 9. Variable expression or a numerical expression? It is a variable expression, and the variable's name is D. Very good. Okay, for objective 2, we're going to start writing some variable expressions. So it says you can translate word phrases into variable phrases. And we do some. We've got them already done here, but we're going to go through them and think about it as we're going through them. First, the word phrase, 9 more than a number y. 9 more than a number y. Well, you've got y. They're telling you have a number. This is your variable. And 9 more says it's going to be plus 9. So y plus 9 is 9 more than a number y. How about 4 less than a number n? So you take the number n, and it's 4 less than that number. So it's minus 4. The variable expression, y plus 9, n minus 4. Okay, how about a number z times 3? So you have this number z, right here, number z, and they want you to multiply it by 3, right here, times 3, or 3z is how we write it sometimes. But you can freely do that when you have variables, and we call this a coefficient. The 3 is the coefficient of this variable term, of this z term here. And 3z is a typical way of writing it, or 4n or whatever, because you can tell the difference between the variable and the number. And so you know that when they're touching like that, it's multiplication. Or you could write 3 parentheses, z, close paren. Sometimes you put parentheses around things to separate them so that you don't get confused as to what you're looking at. So there's 3 for that one. How about a number divided by 12? Well, a is a number, a variable number. They say a number. They're not giving you the number. They're telling you some number. We don't know. You make it up yourself. It's a number. And we're going to give it a variable because it's a number. We're going to give it a variable name. A divided by 12. Or the other way we write it as a fraction is a over 12. That's a number divided by 12. A divided by 12. 5 times the quantity, 4 plus the number c. That's getting tough here. So it's 5 times something, a quantity. Okay? So here's the 5 times. And what is the quantity? It's 5 times what? Oh, it's a quantity 4 plus a number c. Oh, 4 plus a number c. In order to do that, though, since they've said it in two statements, 5 times a quantity, we put the parentheses around it so that we know that this quantity stays together like this. So it's 5 times everything inside this quantity. Or another way to write it is with the 5 touching the paren, which means multiplication because it's touching it. So it's 5 times the quantity, 4 plus c. 5 times the quantity, 4 plus c. Looking at the thing, 5 times the quantity, 4 plus the number c. Okay? Okay, for example 2, we have a real-world problem. The fastest dinosaur may have been the ornithromimus. Erythromimus. I don't know how to pronounce it. It could run about 60 feet in 1 second. Write a variable expression for the distance this dinosaur could run in a given time. Well, so what are the words? In this statement here, there are words that define what they want us to do. So the words are, we have 60 feet per second, 60 feet per second in 1 second. That's this, times the number of seconds. Write a variable expression for the distance it could run in a given time. And since this is in seconds, the given time can be seconds. So 60 times the number of seconds would be 60 something. Let's look at it. So we're going to let s, remember we said we're going to let s equal like something to do with the variable. Well, the variable happens to be seconds. So we're going to use the s. So let s stand for the number of seconds. Number of seconds. You don't have to do this, but it helps you to keep the problem straight in your mind when you do that. So now the expression, the numerical expression, or the variable expression, I should say, is 60 times s. 60 times the number of seconds it runs. S could be 5. Let's say we're going to run 5 seconds. Well, there's 300 feet it went. What if we run 10 seconds? It'll be 600 feet. So this s can be any number we want to stick in there, and when you multiply it out according to this variable expression, you'll have how fast this dinosaur is running in that number of seconds. So the variable expression 60 times s, or 60s, here's where you see him touching again there. Since it's multiplying and it's a variable and a coefficient, we're allowed to touch them like that and not put any operator between them. It's an understood operator, and the operator is multiplication. Describes the distance in feet. This ornithromimus, whatever, could run in s number of seconds. Sorry about that name scrambling there and mashing and killing there. Okay, example 2, check your understanding. Solve is the direction. Solve these two problems. A, bagels cost 50 cents. Okay, dollars, 0.5, okay, each. Write a variable expression for the cost of B number of bagels. Well, it's 50 cents per bagel, and we want bagel, how many bagels? So we know that if we multiply this times B, if we have 2 bagels, we're going to have $1. 2 times 50 cents is $1. So there's our numerical expression, or our variable expression, excuse me. $0.05 times B. Okay? And now, problem B. Write a variable expression for the number of hours in m minutes. Well, how many hours are in 60 minutes? Well, it's 1 hour is in 60 minutes. Oh, how do we get that? We put 60 divided by 60, right? So in this case, we know how many minutes we want. We want m minutes. Okay, so it's going to be m minutes divided by the number of minutes in an hour. divided by 60. And this is your variable expression. If you had a 60 for m, 60 over 60 would be 1 hour. If you had 30, 30 over 60 would be 1/2 hour. Okay, so that's how this is done.